Hello, we have already introduced what the Teleprotection C37.94 service is and how it's deployed over an SRv6 network. Today, we are going to explain how to deploy the service over MPLS-TP. We won't go into C37.94 interfaces and interface card here. If you are interested in learning more about the topic, you can watch the separate video about the Teleprotection C37.94 service over SRv6. MPLS-TP is a transport technology and integrates MPLS packet switching with traditional transport network features. Its OAM function can effectively detect, identify, and locate faults for services, quickly switching the services away from faulty links or nodes. For example, MPLS-TP OAM can detect the running status of the primary PW. If the primary PW is faulty, services are quickly switched to the secondary PW for protection. In the electric power industry, it's advisable to deploy E2E static bidirectional tunnels to ensure service stability. The deployment roadmap consists of 3 steps. First, create 2 static bidirectional core-routed LSPs, one as the working path and the other as the protection path. Then, create primary and backup tunnels and bind each of them to the corresponding LSP. Second, create a static PWE3 service and bind it to the primary MPLS-T tunnel on the serial interface. Then, create another PWE3 service and bind it to the backup MPLS-T tunnel to function as the protection PW. Deploy PW-APS and associate it with OAM detection for a primary-secondary PW switchover. Third, deploy MPLS-TP OAM to detect the status of the primary PW. Use the CC detection function and you can adjust the detection interval. If the primary PW fails, MPLS-TP OAM quickly detects the fault and works with PW-APS to switch traffic to the protection PW. Here, you can see the test topology and the test procedure. We now log into a device to introduce key configurations and check the results. First, activate MPLS and MPLS-T capabilities on the device. Then, deploy 2 static bidirectional core-routed LSPs between duty 1 and duty 2. The primary path is from duty 1 to duty 2. The backup path is from duty 1 to duty 3 and then to duty 2. Configure duty 1 as the ingress node, duty 3 as the transmit node, and duty 2 as the egress node. After the configurations, check the status of the created LSPs on the device. The result shows that the LSPs are in the normal state. Next, create two static MPLS-T terminals and bind each of them to the corresponding LSP. Check the status of the MPLS-TE terminals. The terminals are up. Create terminal policies to specify TE terminals. Now, assess the service interface and create primary and secondary PWE3 service. Bind the primary service to the primary MPLS-T terminal and the secondary service to the backup terminal. Deploy PWAPS for them. Configure MPLS-TP OAM to detect the status of the primary PW. Set the CC detection interval to 10 milliseconds. Check the PW service state. The primary and secondary PW services are up. In addition, you can see that MPLS-TP OAM has been deployed for the primary PW. After deployment is complete, enter the tester interface view. Check that the services are running properly. The tester calculates the one-way delay of service transmission. Simulate a fault on the primary PW by shutting down the interface. When the primary PW is faulty, services are switched to the secondary PW and run properly. The switching time complies with the specification. That's it for the Teleprotection C37.94 service over MPLS-TP. Thank you for watching.